And now we are going to speak about an efficient algorithm for clustering, the Lloyd algorithm. First of all, why we do not like the farthest first traversal? By definition, when you select the farthest point, you are getting in a trap. Experimental errors that will have extremely unusually high or low values. It is clear to us that this point and this point are due to error, the top left and the one in the center. And this is composed in reality by a green cluster, a red cluster, and a blue cluster. So we are going to remember our understanding of statistics, the variance mainly, and what we wish to have is a distance, a distortion, that measures the sum of the variance from the data to their centroid or center. And this is the k-mean clustering problem. It's very nice. As input, I have a set of points data or array and an integer k. As an output, I will have the cluster. Unfortunately, this is not a feasible problem. We cannot compute it for k more than 1. Why do we need to compute it for k equal to 1? Because that is what the Lloyd algorithm will use for clustering. So, first of all, we report the center of gravity theorem. They say that, first of all, the center of gravity of a group of vectors is the only vector solving the one mean clustering problem. And we remember that given a set of vectors, the center of gravity is the average of these vectors. And now we are going to report the Lloyd algorithm. We initialize randomly k points as centroid from our dataset. And as step 1, we assign each point in the dataset to the nearest centroid, even if the centroid were randomly selected. Given these clusters, I'm going to create a center of gravity of each cluster. And I'm going to return to step 1, and I'm going to assign again each point to the dataset to the nearest centroid. And I'm going to iterate until convergence. Will it converge? The good news is yes, it will converge. The bad news, to a local minimum, not to an optimum minimum. As a consequence, we will have to run several times on different starting points in the hope to find the correct one. Now, I'm going to introduce the next video. The next video on soft clustering. As you can see, when I have to cluster these points, I find myself in an awkward situation. It's very easy to cluster the group on the left. It's very easy to cluster the group on the right. But it's very difficult to know the point in the middle to which cluster is owned by. So this will be the next video subject. As usual, I'm going to report the book.